All right, according to YouTube, we are live now, so go for it.
All right. Okay. Hello, everyone. So this is day 4, and we've finally switched games. We're going to spend the next few days, maybe 2 or 3 days, talking about NIM, and then probably most of the month secretly talking about NIM. All right. So this is the book. Again, this is, I think, in the list of references on Neil's page, this would be book 1. The article looks something like this on the right. I'm going to not get into tactics right now. I'm only going to set up in an attempt to make this last less than an hour. I'm going to talk only about NIM because I'm going to talk about more NIM-like stuff tomorrow. All right, so what is NIM? So this is supposed to be a table. On this table, there are 3 rows of, say, coins, counters, whatever you like. Players take turns. They can remove as many tokens as they like, so long as it's from one horizontal row. So like either this row, so there are 3 rows, row 1, row 2, row 3. Take as many as you like. And I'm just going to, walk us through one sample game. So as with the previous readings, we will first take it just by looking at one sample case, and then maybe we'll talk a little bit about what kind of observations we may be able to make, some generalizations. Okay, so player 1 comes along. So here's the board as it existed in the beginning. Player 1 comes along, and this was just an hour ago and I can't remember what player 1 did. Let me just take a look at the board. Player 1 has removed these 2 tokens here. Right, so remember, you can remove as many as you like so long as it's from a single row. Player 2 comes along and removes this whole entire row. Player 3 has removed this token. I'm sorry, player 1 has removed this token. Back to player 2, and etc. All right, so this just being a sample game, I can't really say whether it was played in any way rationally, optimally, anything of the sort. But if you come down here, let me try to argue from this point forth. So supposing you're able to reduce a board to just 4 tokens. Okay, so maybe if somebody'd like to play against me, let's say this is the starting board that perhaps I have left you, right? This situation in which there's 2 rows with 2 tokens. If anybody would like to make an attempt at playing it, or we could actually just step through the cases as I will in just a minute. I would like to be able to convince you that
Yeah, sorry, I think you have to turn on annotations. So
oops, I'm so sorry. I apparently have to be told every day. Sorry.
it's fine.
Um, hopefully now.
Yes, thank you.
All right, and again, so you've got a board on which there's 2 rows, 2 counters in each row. The rules of the game are take as many as you like, but it must be from a single row. Does anybody want to give it a shot? I mean,
There's a question in the chat about the win condition.
Okay. So on your turn, so it's the same with as with tic-tac-toe. On your turn, if you cannot play, so if there's nothing to take. So in this particular version of the game, player 1 has won the game, though perhaps we'll see later whether, I mean, again, I'm not claiming in any way that this was optimal play. All I do want to, I would like to, however, look at the board from this position on. If you can get the board, so now player 1 has done something and has managed to clear out the board. When player 2 comes along, there's nothing to do. Player 1 wins the game. And I'd like to convince you that if I were to start with this board situation here, this one, that no matter what you do, I can get to. So whoever gets a board straight to this position can get it to the end position, is the claim I'd like to try to convince you of before we start doing this a little bit more carefully. for which again, if there are no volunteers, maybe, oh, thank you, Neha. He has cut off 1 on the top. All right, so I respond by doing that. And this is a strategy that perhaps last player to pick loses. Well, I'm the last player. I'm going to take this away. And unfortunately, I set Neha up. And so the last player to take a token actually wins because there was a move left to them, and the opponent had nothing they were able to do. So essentially, yeah, does that make sense, Nilesh? All right, I'm gonna hope. Yeah, I mean, right, exactly. I mean, the opposite in the sense, yeah, I could set up the Misère version of this as well. But for now, the game I'm looking at is whoever takes the last token wins. All right. Okay. So, okay, so let's pretend that this is a board. Thank you. All right, and this is the board state after play A has played. Okay, if that's the case, let's actually run through everything that could happen. Player B comes along and player B can achieve one of these 3 possibilities. So what player... I'm going to use the fact that these are 2 rows of equal length so that the board isn't overwhelming. Let me walk you through what I've done. So in case 1, this counter was removed. Okay, this is how you got here. In case 2, these 2 counters were removed to get us here. Or finally, I mean, I think at this point I'm belaboring this point, but all 3 were removed to get us out here. So there are 3 things you could do, and I'm sort of making a call to symmetry to say whether I did the same thing. Well, this is not true. I have left out a case. I could have taken away a counter here, right? I could have had a 1. All right, so I've got a missing case. What have I missed out? Let me fill in. Maybe I've missed more. If I have, I'd be very grateful if someone told me so I can fix the slides.
No, but that's the
No,
first case
that's
only,
afterwards.
right?
Okay, I can only remove from 1 row. This is fine. Yeah. Sorry. Thank you. I could pretend that was me checking if anyone was listening, but it's not true. I just completely mucked up. All right.
So I think here the second player can replicate the same number in the other row and take it to the previous position.
Wonderful. Okay, so let's talk about that. Yes. Okay, so essentially reminiscent to tic-tac-toe, the strategy. Okay, let's there are several things that, so let's work with board state 1, for instance. So were you talking about, all right, maybe let me undo that. Okay, could you tell me what you were thinking?
So yeah, if B has taken, A has taken 1 from the top row, B will take 1 from the bottom row. And if A has taken 2 from the top row, they'll take 2 from the bottom row. So the idea is to leave equal number of coins in each row.
Exactly correct. So because this is a starting position in which the rows are of equal length, and we've already figured out that what we would like to get our board state to is something that looks either like that, right? Or like this, or even better yet, finish at once, empty the board out, right? These are the things, this is what you would like to see. So yes, you're quite right. Whatever the first player did, you mirror, and this is how I would like you to think about this extension. If I had started off, so we argued this for just this position, right, in the previous.
Yeah.
Yeah, but this could be extended to, I could put any number of equal counters on these 2 rows, and the same argument would work out for us. So, okay,
so it means that if there are only 2 rows, then those rows being equal always leads to
Correct. So
Winning.
whoever receives a board state with two heaps, two piles of equal length, yes, they will be able to win the game by
And if
playing.
and if they are unequal, it's the opposite
Wins.
because that person
Well,
will give you the equal position.
okay. So that's a little more tricky. So let's talk about that next. All right. Okay, let's do. Okay. So again, there are
If somebody receives equal number of counters, they will lose the game, not win the game. Somebody receives 3 each.
If you receive, sorry, yes, this is true. If you receive, so if you are able to achieve a situation in which you're handing off, I was trying not to do the previous player, and I managed to make it worse. But hold on, yes, exactly correct. So so in this situation, player A has completed their turn and has left a board state that looks like this. Right, I swapped it up from my previous page because I will need it in this form. But if at the end of player A's turn, the board looks like this, then player A will be able to get us to the empty board. We'll be able to win the game. Okay, one second, let me just check chat. Random cut.
I think the question was, can you pick tokens? Like, do you have to pick tokens consecutively, or can you pick them from anywhere? So it's just saying that only the numbers matter, so it doesn't matter.
Anyway, but you can't, you have to choose from a single pile, that's all.
A single row, yeah.
A single row, yeah. Okay, all right. Okay, so again, so so at the end of their turn, A has achieved a safe board if they know that the thing that they hand off results in a win for them, right? So they would like to hand over to B states which are safe for them. Okay, so this nomenclature, this terminology, I think no matter where you read it, can be confusing when someone says it to you. It's a lot less confusing if you work through it. But okay, so as with the previous condition, if after A plays, they have these nice symmetric piles, they know that's a safe state. And okay, so let's talk a little bit more about what a safe position means. So if you believe, so this is, if a safe state is something from which A can force a win. So anything you do to it makes it unsafe. So no matter what B may play, they end up with a board they cannot win. So an unsafe board. Okay. And from an unsafe board, there's something that will get you to a safe one. So these are the two things that we're going to try to break down and look at today. Okay, so far so good? I'm going to, all right. Yeah, all right, thanks. Okay, so now let's walk through a small portion of the game tree we looked at before, all right? So that was a safe state for A. So A has finished playing, he has left behind this board, and from here, A knows they can force a win. From that state, anything that is done ends with an unsafe state. Of the next viable set of actions for A, now we're back to the A players board. When they finish playing, there is one of these boards. So we're assuming that A knows how to play strategically and can switch the board state into something that's safe for them, right? And so what we're going to do next is just to try to figure out how to do that. All right, B is unsafe. All right. Sorry, was someone trying to say something? Yeah, Nilesh?
No, nothing. Sorry. Yeah.
Yeah, that's it. All right. Okay, so now let's look. Okay, so one more. So somebody asked, I think I can't remember who, but somebody asked if what you're looking for is a perfectly symmetrical couple of rows, same number of tokens in them. And we said, yes, well, that handing that over. So if you manage to play into that state, you're golden. But what about this one? Is this a safe state? If I were to hand you this state, would I win the game? If I'm able to reduce a board to this state, is it a win for me? Okay, take a minute to guess, and then we'll simply run through the cases and talk about it. And then we will figure out how to do it without having to write out all the cases. Yeah, maybe that's too much. All right, so yeah. Do I win? No. All right.
So if I pick from row 1 or row 3,
Mm-hmm.
the other player can take it to safe. So it's unsafe for me.
Okay, let me just do this. Let me show you the first set of possibilities. So what could I do? Well, I could take, like you said, I could take the top one off. I could take one off the second row, maybe all of the second row. That's these first three options. Then I could take one off the last row. I could take two off the last row, or I could just knock off all of the last row. Maybe this is a little easier to look at. And remember that if a board state is safe, it means no matter what you do to it, it's now unsafe. And with an unsafe board, there's a specific move I'd be able to do to get it to a safe state. So can we look at any of these and say anything about them? Or maybe can we mark off some ones which we...
I think position 1, 4, and 6 are one move away from safe.
All right, so move away from safe is unsafe, right? Anything away, right?
Yeah.
Yeah, so you're saying this one's not. I mean, do I
Yeah.
want... Yeah. No, sorry.
Because they can pick the third one from the third row. Yeah.
What do you mean by one move away from safe? As in, okay, you can convert it to a safe position for you.
The
then.
opponent can, it's safe for the opponent, right? It's basically the opponent can make it symmetric.
Correct. Correct.
Correct. Hold on, let me just... Okay, so we're saying that's not good. How about this guy?
No, I was talking about 1, 4, and 6.
1, 4, and 6, because they're similar to something we saw. All right, how about then let's look at the ones that are in between. What about the rest of them? What would you do here? Is there any...
I have a question. The first board which is given is played by A, and these are the possibilities that B can make. The 6 ones,
Exactly,
right?
exactly. So A has done something
Huh.
and is very is quite pleased with themselves. They've handed this over. So this is after A has played.
Okay.
Okay.
Sure. Thank you.
That's fine. All right. So okay, maybe let's maybe
I
with
think, I think the other threes are also unsafe.
Okay, why?
So in the position 2, I can take out the entire bottom row.
Yep.
In position 3, I can take out 2 from the bottom row.
Yep.
And in the position 5, I can take out the middle row.
Yep. All right. Wonderful. Okay. So yeah, I guess I haven't listed I have not listed all the possibilities. I'm saying now that we are playing rationally, this is what you would attempt. This is exactly what you said. Remove this row, remove this token, remove these two. And again, I don't think at this point I'm belaboring it. So yeah, remove that. All right. Okay. So now, well, maybe I don't want to go around listing. I would really rather not have to draw this whole entire tree. So is there something about this heap that I could look at, the set of tokens, the set of rows? And maybe is there something I could do to figure out? Okay, so the next order of business is to try to characterize these things. All right, so when there was a single token in each row, we said it was sort of a mirroring argument, that whatever you do, I do. It's some sort of a parity argument. There's something about its symmetry that is helpful to me, right? If I hand you this, because whatever you do, I can then follow. So the thing that I'm looking for so I'm looking for a property that is preserved. Like, so if I I'm looking for something that can always be brought back to. So if no matter what you do to the state, I should be able to bring it back to a safe state after, and there is nothing you should be able to do that can make it safe for you. Okay, so I'm going to just show you how to go about this. All right. So if I were to write out these numbers in binary, so does anybody here want me to walk through how to do that? And again, even if it's one person, I'd like to do it. So is it all right if I were to write 1, 2, and 3 like this in binary? And here, this is. Okay, so maybe I will still just. Okay, so let's say the number 3. I mean, maybe I could just count. All right. So again, so binary means I can count only because I've chosen small numbers instead of trying to do a complete conversion. Let me go about it this way. Let me just count in binary. Let me go. I want to do the decimal numbers 1, 2, 3. Ouch. Okay, so 1. Now, well, I don't have any other digits, so I move over a place. Okay, so that's how, I mean, I've tried to keep it to simple numbers for now. But again, and now what you do is after you've listed every heap, so this is not, it's the number of heaps matters, as do the number of tokens in each heap. So it is a little hard to see what kind of argument to make here, but let me show you what does work. Then you check in each place.
Jyoti ma'am,
Yeah.
the
Yeah.
binary here is
Huh?
for the row number, or is it for the number of
The number
tokens
of tokens per row. All right, so I've written out the 3. So row 1. Okay, let me clear up all my mess. Hold on. What I'm going to do is I'm going to say, well, here's the board, right? I know that, so the number of rows tells me how many numbers I have, right? 1 second, I'm just looking for a property. Okay, so Neil's got a more coherent version on the chat, but let me try to give you the heuristics first. Okay, so, all right, sorry. Okay, so right, so there are 3 rows. Oh, I see. Because I chose 1, 2, 3, I could be numbering the rows or the tokens. Yeah, apologies. I'll do it again for a non 1, 2, 3 number. But yeah, so this is that there is 1 token.
You have one on the left. I think it's fine, Jyoti.
Okay.
Yeah.
Okay. So yeah, so these are the numbers corresponding to the number of tokens per row. The number of numbers that I have tells me how many rows I have. I go through it bit by bit and I check for parity. So I check whether I have a even number of ones or an odd number of ones. And for anybody, this is an XOR operation, but let's just look at it bit by bit and say, if it is even, I put a 0. If it is odd, I put a 1 down. And the claim, which again, I'm not making precise today, I'm just going to say that if I can get to the 0 state here, then these boards are safe. Okay. So, sorry guys, hold on a second.
So if you are looking at only the last bit, then
Yeah.
only even or odd matters, right?
Okay, hold on. Let me just give me a second. I'll come back. I'm just trying to clean up. Yeah, hold on just a second. I'm just trying to prevent, I want something to show up after. I want you to have a shot at it. So I don't want it to be visible. So I'm just trying to sort that out. Give me a second. Okay, that's it. Okay, could you say that again? Sorry, someone was saying something when
I mean, if you're looking at only the last bit, then only the evenness or oddness matters.
I'm not looking only at the last bit. I'm looking at each bit. Okay, so I'm saying here,
Okay.
right, there were two of them, hence 0. If I go and look at the next signal, this bit, two of them, hence 0. Okay. Does that answer?
Yeah, okay.
Yeah. Okay. So now, what about this one? So I'm not going to do anything. I'm going to give you a second. Is this a safe board? Anybody wants to do it on the board, that's fine. If anybody wants to give it I'll give you a couple of minutes.
So the fact that the numbers in binary added up to 0, did you mean that as some sort of a hint that folks can use? The safe boards previously had that.
Well, no, okay, sorry, do I give more of a hint? I said write out the numbers in binary, put them, I guess this is why I have to do XOR. All right, because there's no relationship between these numbers if I'm just, oh, well. Okay, so essentially what I'm doing is I'm kind of listing the numbers out, and then I'm sort of making them into a table sort of, and I'm comparing, just looking at it column by column and checking whether the number of bits in that column is even or odd. Someone please ask me a question. Neil, do you want to say that again?
No, that's fair. I think, yeah, I mean, I guess I was just noticing that when you did that, you ended up with a 0 and on both of these boards, and both of these boards are what we called safe positions.
Correct. So, yeah, that was the attempt to show that both of these, yes, I never said that, did I? Yes, I'm making the claim that a safe board is one in which you can get to 0. In this particular sequence of actions, which may be, okay, nice.
Yeah, okay. So
You should not violate P. Hold on.
that's fair. I think you can, I mean, that was in the context of what I put in the chat a moment ago, and I think that's fine. P being the property, not previous player. This attribute property that you wanted, that you were talking about. So yeah, maybe you want to go back to the board that you asked people to think about. Sorry.
Neil, so I haven't read what you put in the chat. Would you copy it for me and keep it for later?
Sure thing. Thanks. Yeah.
All right. So here's the board. Question is it safe? I have a few comments. I'm going to give us a few more minutes. Maybe if you want me to move, I mean, if I see a few more responses, we will move on. Unsafe, all right. Okay, so let me start working through it. This is a problem with animating at the last minute. All right. So unsafe. Yeah, perfect. Wonderful. So the way we went about it again is to list out the numbers into a sort of table. Maybe I should put a 0 here. after which to break it into columns, check if the number of ones is even or odd. If it's even, put in a 0. If it's odd, put in a 1. And if this is not a 0, 0, 0, it's an unsafe board. How do we get this? Okay. Yeah, okay. Maybe in Saturday's class, Aditi. Maybe in a more formal class if we can totally figure it out by then. But for now, it does look to me also like a little bit of magic.
I mean, I don't know if there is, okay. So I guess there are two questions here. One is, why does the rule work? And the other thing is, how do you come up with the rule? So the answer to the second question, I suppose, is harder, and I'm not sure that we know. But in terms of, if I don't know if the question is, why does the rule work? That is something that
We get the school rule. So I think,
Yeah.
all right.
The question was, why does this work? Like,
Why does it work? All right, that's easier.
yeah.
that's an easier question to answer.
That's
Yeah.
easier. Yeah. Neil, do you want to
No,
do?
but is there some intuition as to
Yeah.
even if you can't
Yeah,
show it,
so
why are we doing binary and not base 3 or
not
base
something
4 or
else.
something?
Yeah. No, we haven't fully convinced ourselves yet. We have a class to teach on Saturday, so maybe by then we'll have more clarity. And if we do, we'll come back and say it here as well. But yeah, I don't find anything in the literature that motivates it any better than here is an XOR operation and it works.
So I don't
Yeah,
know.
so maybe go do your, the thing that we were talking about today.
Do you want, I don't know, I can take a small detour and talk about a variation that might help with some intuition, but it won't, I mean, I should not do false advertising. It won't motivate the specific rule, but it's just some maybe general thing about how you would probably think about something like this. So I don't know, I could take 3 minutes to talk about that, but I don't know. Jyoti, are you okay with that? With like a
Yeah, definitely. Yeah, of course.
All right, so I think hopefully folks in the chat agree that we're looking, if you read the chat, you agree that we're looking for this property P, which gives you this kind of control that if the property is not there, you can restore it. And if the property is there, then no matter how you move, that property is destroyed, right? That's the sort of thing, that's the sort of structure that we're looking for, right? So for example, I don't know, let's just for 2 minutes think of this variation of NIM where you're only allowed to remove an odd number of tokens. Exactly the same game, but you cannot remove an even number of tokens on on anybody's turn. So both players remove an odd number of tokens. Now consider the following property of a set of numbers. Let's say the property is that there are an even number of even numbers, right? So let's say you look at the piles, you count how many piles are even numbers. Yeah. Then, okay, let me write out that property because maybe it's not easy to, I mean, I guess I will also get confused. So consider the following property, okay? The number of piles. Yeah, so the number of piles that have an even number of tokens is even, okay? Now, what can we say about this property? If you remove, suppose you have this property, right? Then if you remove an odd number of tokens from, from any pile, so if it's an even pile and you remove an odd number of tokens, you flip from even to odd. And if it's an odd pile and you remove an odd number of tokens, you flip from odd to even. So if the property holds, then no matter how you play, you have disturbed the property. On the other hand, if the property doesn't hold, so there are an odd number of piles that have an even number of tokens, that means there's at least one pile that has an even number of tokens, and I can just remove one token from it. And then that pile goes from being even to odd. So now I have removed one of the even piles. So if there were an odd number of even piles, now there are an even number of even piles after I make this particular move. So if the property is violated, I can restore it with one move. There is at least one move that's valid and that restores the property. If the property holds, then no matter how you play, you are going to destroy this property. So this is the sort of thing we're looking for, except this property doesn't quite work for standard NIM, and you can verify for yourself that, that this doesn't work. But a more, I guess, an extended version of this property works. So to say that the XOR sum of a number of numbers is 0 is to say that, well, in particular, the number of odd piles is even, and then the blah, blah, blah. I think it means something in terms of the numbers. And there is, okay, the mechanics of showing that the XOR sum being 0 is a property that has this property is that's not hard to do. But how did somebody come up with this idea that this is the thing that works? I have no clue. But when somebody tells you, it's not hard to verify. So the intuition that you're asking for, when honestly we don't have, and right now, but at least for a simpler variation of the game, I think you can at least see what is it that we are looking for. I have no idea if that was a helpful tangent, but okay. So Jyoti, I will let you continue making sense and not interrupt.
No, thanks, Steve.
So there is some intuitive
there is.
way of deriving it, but I've forgotten. Let me try
Okay.
and see if it
Do
can
you
be
know
helpful.
of I don't know, because this is
I mean,
not.
the first time you solve it.
Yeah, no, is it something to do with the whole flipping back, me getting to any state?
No, I remember.
Yeah, with two piles, I think you can sort of see that. I mean, the property that holds.
No, 2 piles is easy. I think the idea is to look at 3 piles.
Yeah.
And work through some detail, and then you figure out that this is probably what we want.
Yeah, so I'll give this a swing by yeah, exactly. So maybe we could all
Yeah, we could think about it, because I think we did think a little bit about the zeros or sum and what does it mean for the numbers. And this was the closest that I could get in terms of, it feels like a parity condition. And on this much simpler game, I think, yeah, I have a sense of what we're looking for, but I don't know why specifically the Zorsum works for the original version of the game. I mean, we know why it works. Just to be clear, the proof that the XOR sum being 0 is the property that we are looking for. That proof is not really hard. It's just, I think it's just the question of how does somebody see that this is what we should anticipate? I don't know. So I remember I kept telling Jyoti today that if we work out the proof, we'll be able to, reverse engineer the intuition. But I think that was, uh, it didn't quite work out that way. Let's see. So we can, I think I don't know if you're planning to do the proof, but the proof is not hard. I mean, the hard bit, I think, is how do you come up, or how do you realize that this was the condition that characterizes the winds? So yeah, and this I don't know.
Yeah, I mean, so again, because as an outsider's view, you're saying this has nothing to do with parity flips, and when you have, error correction sort of stuff, you can't link this back there at all.
Well, I think it does have something to do. I mean, XOR is basically all about parity. So I think in some sense there is a connect. I mean, whether there's a connection with the error correction in particular, I don't know. However, even with the simpler variant with an odd number of tokens, and that other property was purely a parity thing. And I feel like that's one step, or I don't know, maybe a few steps away from what's going on with the general version of the game. But I don't have that. I don't have that bridge yet. But I think, okay, given that, I mean, okay, so there is the question of intuition, of course, but I think even when somebody tells you that this is the rule, I think it's still like a few minutes of work to validate that, that the rule has the advertised property, that you can always snap back. In particular, what we want to show is that if a bunch of numbers have a XOR sum of 0, then no matter what move you make, the XOR sum will no longer be 0. And if the XOR sum is non-zero, you can always find at least one clever move that flips the XOR sum back to 0. This does require, I think, an argument, at least for somebody like.
That's the thing, Neil. If you don't bring it up at all, like I managed to do today, like if you don't say XOR sum at all, and you say just parity, then okay. Hold on. Don't say any more, because I want people to try this. Okay, hold
Sure.
that for a second. Yeah.
Sure.
Sorry.
No, I mean, the Zorsum was just a shorthand for saying parity, so it didn't mean anything deep. So yeah, you can
I
continue.
mean the whole like the proof we worked out today. I mean not the yeah, which we will do more formally, I guess, when we do this formally. But okay, so the question, so to whoever's still okay, so the question is, how would I flip this back? So I know, right, let me see. Do I know? Oops, I don't want to laser pointer. Hmm. All right. So I know it's okay. So this is not a safe board. We've established that. And the question is, how do I make it a safe board? So the issue that I seem to have is this one, right? So I don't want this one to be here. So can someone turn this back um, into the board and tell me what to do?
If we remove two tokens from the first row,
Correct.
that will become a 0.
Yeah, okay. So essentially, you're saying I want a
Yeah.
0 there, but I do want to retain the 1 in the last position. So I do want this one. So
Yeah.
I get rid of this, which means basically remove. Oops, and I wrote out the 1, but yeah, these are gone. Okay, so yeah, perhaps not completely satisfactory, but this is an introduction to what will be a couple of conversations about NIM. So, okay, and that's all I wanted to say today. Does anybody have any questions about the mechanics of it, even if we've not really.
So the
So I have
problem
a
we're
question.
talking about here, I mean, one example, at least an analogy, is multiplication by -1, right? It always takes you to negative, and then you can always bring it to positive.
Yeah, well, sure. Yeah. Okay. Hmm. That it's a yes, that it has a similar.
That's because it's a two-player game, right? If it was a, like, is there a variant which makes it a three-player game?
Well, at this moment, where
Because in that case, you want to get to a winning position after two moves and not one move.
I mean, so I don't know that 3-player games have the kind of yeah, I don't. So the kind of analysis we are doing right now, we are situating it exclusively in the 2-player context. I don't really. I mean, I play a lot of 3-player games in real life, but in terms of the analysis, I wouldn't even know where to start. And again, so anybody who does have some idea, please do jump in. But is it as clear as that? No, I don't know. I don't. So to your point, just saying that it's like, a safe, that's something that flips between the two. To draw an analogy to -1, it gives you a sense of it, but maybe not a way to do anything analytic with it. So I don't know. It's nice to perhaps have that intuition, but I don't really know. Yeah.
Okay.
Yeah. Right. Okay. All right.
So in a three-player game, I think then it becomes uh, so if it's a safe board, then second player will never win, right? Either of the first or third player would win.
So again, the kind of combinatorial analysis we are up to right now, I don't know how they extend to 3-player games, right? So the assumption,
No, all I'm saying is that we can come up with some property which can help us ascertain which of the three players will win a particular board, form a particular board position.
right, except, I mean, so, are there win conditions for it? I mean, Yeah, I don't know is a simple answer to that. Maybe, I don't know.
Achha, I have another question. In this one, right? What if, let's say, there was yet another one in the second row?
If there was, wait, hold on. Are you talking about, would you just write it on the thingy?
Yeah, so if I can, so let's say if there's another thing over here, now how do I make it safe?
I'm not seeing it. All right. Another token there.
Yeah, so that means that this is also one,
So this here is a
and
one.
this is also one.
Right. So then, okay. So would you like to give it a shot? So you're saying, okay, let me write it out. So you're saying that it's 1 1 1 0 1. Oopsie. 1 0 1. This is actually easier if you just look
I remove both the tokens from the top row.
all three of the tokens from the top row. Yeah.
Yeah.
You want to get rid of
And,
all
Yeah,
those.
right.
and is it always possible to go to a safe position from like I don't like any board that is given to you? Is it possible that we can always go to the safe position?
Correct. This is the claim. Yes.
Oh, this is like we can.
Yes. From an unsafe to a safe, there is a path. From a safe, any path is to an unsafe. So there exists a particular move that gets an unsafe board to a safe board, and anything you do to a safe board gets you to an unsafe board.
Unsafe board. Okay.
Right. And so what we were up to here is trying to figure out which move it is that gets you to the safe board.
Okay.
So it's like one move, not like a combination of move which will take you from unsafe to safe.
But were it a combination of moves, by then the other party has a chance to intervene, right? So when you say safe and unsafe, you're talking about the
One move.
yeah.
And the combination of moves will be like it cannot be continuous now.
So
The
you
second
take a
player.
turn, I take a turn, and we proceed until the end of the game. Again, as with tic-tac-toe, the aim tomorrow will be to come and look at things that don't look like them. Yeah. There's lots of stuff happening in the chat that I've not been able to take a look at. So, Neil, I hope that
Nifty's pointed to a nice code forces blog, which I will add to the the website for the reading group, so people who miss the chat can still go and look at it. I think there is some attempt to motivate the czar by essentially saying, yeah, I don't know. I don't know if it's worth getting into it here, but I think basically they say that, well, let's try and associate a number with each NIM game and hope that the number gives information about the game. If the games are single pile games, the most natural number to associate with that game is the size of the pile. And then they say, well, how would these numbers combine if you were to combine two NIM games by just putting the piles side to side? And then there's some blah blah at the end of which they say, okay, look, the way these numbers combine, the only way it could possibly be is through this. I mean, there are some natural properties, natural as per them, that this that this composition effect should satisfy. And they say, well, basically boils down to group of order 2, and that's where they say that, well, it's now the only thing it can be is 0 1 and the XOR operator. But I don't know.
that all feels like the mathematics. So like
Yeah.
I was saying today, that at least something that makes me see the mathematics, not here are the mechanics that clearly work. So I still don't see it. But
Yes, we should take a closer look at maybe
yeah.
certain I mean for maybe I think for people who think a certain way, this is all perfectly natural. To me, like I said in the chat, it feels like well, I mean, it feels like a lot of leaps of faith in the beginning, but maybe it's not as maybe I'm not really being fair by saying that. So we'll probably have a longer discussion about this
I don't
offline.
think the
Anyone
thing about it is a technique works.
Yeah. No, I do start from first principles, saying that, well, let's try and see where this leads us. And they try to, I mean, I think there's a little bit of hindsight playing a role, but they try to make it sound like, oh, where else could you land up except for the XOR operator? And that should make you happy, I think, if you're convinced by that line of reasoning. So longer offline conversation for some of us at least, and anybody who's intrigued
If
by
any clean summary comes of it, we'll bring it back here.
take a look at
Tangential question here.
Mhm.
Has there been any algorithmic paper on NIM? I mean, I don't remember anything. I'm just asking.
Has there been?
For example, if suppose I give you very large numbers, right? And then you're supposed to play it physically, and it will take a lifetime for you to take a number, convert that into binary, and so on. So, is there another algorithm? I mean, XOR may. I mean, whatever we currently have probably is a solution, is a mathematical solution, but it may not be algorithmically efficient.
Oh, that's one for Neil for sure. Algorithm.
Really efficient to to XOR n numbers is exponential.
No, suppose I give you some 1,038,000 something.
Yeah,
And
okay.
it'll take you a long time to. So, and let's say we're playing it mentally or something, right?
Yeah, so you're saying
so you can't use paper and pencil and convert it into binary and do all that.
Is there some other intuition that helps you play
So
it?
somewhere there must be problem. I mean, I don't know whether there should be, but there must be something, no? That's to help you.
This I have to check. I think the current algorithm, like you said, would probably be, I don't know what we call pseudo polynomial or something, I suppose. So yeah.
It is. I mean, I have no problems with that. I'm just saying that.
So the natural algorithm is pseudo polynomial. Can we do better? Is it like subsets?
Can we do it mentally if the numbers are large?
They're shortcuts.
If the number are large, and I mean, suppose you had only 2 piles, right? Even if the numbers are large, I don't care. All I need to make sure is that the 2 piles are equal, right? But what happens if I have 3 or 4 piles? Then I don't want to look at the semantics of the numbers and do something.
No, this was exactly the thing that, we will definitely. I mean, forget the large piles, even with a small pile, and if I had an intuition of what to do other than sort it, I think that could be a first step. So maybe it all boils down to why the sort again.
Is XORing the only solution though?
This we don't. This is the question that. Yeah. Sorry. Go ahead.
Is
Is
that the only property which will solve this?
No, it's not the only property, but any property that will solve it will be equivalent to the XOR. Because XOR is complete.
Okay.
But there could be a simpler way of characterizing it, but that is something we have to see.
Yeah, that's worth thinking about. Okay.
Yeah, okay. I think, it's homework to figure out the complexity of NIM in the sense that when I was asking, I'll try to, if I find anything, I'll be sure to let you know. Yeah. Oh, yeah, that's a great question to wind this up on, I suppose. Yeah.
Okay, good night, everyone.
Okay, thanks very much, everyone. Good night, and see you back tomorrow at 9.
Bye.